All right, from yesterday's assignment, page 125, number 33. Did you try this one? And if so, what did you try?
Well, I looked at Calc Chat and I tried to follow from there, but I just didn't really understand still.
Okay. It's definitely a quotient rule problem because there's a top over a bottom and there's no way to just divide x minus 3 into the top. So there's no getting around the quotient rule on this one. There is an algebra thing we could do. I don't know what Calc Chat did, but if you don't like the 1 over x, since it's a fraction and a fraction, I would multiply top and bottom by x to clear out that denominator. So again, this isn't even calculus yet. This is algebra. And I think that's a better looking thing to deal with than this thing. Partially because I don't have a negative exponent or a fraction anymore. So now that I did a little bit of algebra, I didn't get out of doing the quotient rule, but it still made my life a little easier. So the derivative of the top would just be 2. The derivative of the bottom would be 2x minus 3. And now I'm ready to do the GF has to come first, right? In relationships and in calculus class, the GF has to come first. So GF prime, so 2 times x squared minus 3x minus FG prime the other way, 2x minus 1 times 2x minus 3, all over g squared. Free response question, say stop, you're done, I don't want to mess with the algebra. Calc Chat, back of book, multiple choice, they're going to do some algebra with that. At least clean up the top to see if something happens. 2x squared minus 6x minus, and I got to FOIL all that, 4x squared minus 6x minus 2x plus 3 all over the denominator. I'm going to be lazy and not even write it, as long as I don't forget it. So 2x squared minus 4x squared would be negative 2x squared. Negative 6x, I'm doing a lot at once here, I hope I don't mess this up. Negative 6x plus 6x goes away, plus 2x, and then minus 3. And I don't know if I could do anything more than that or not. And that might not be what Calc Chat or back of the book says, but it would be equivalent to what they did. Does that look familiar, or do you remember?
I think that's what it said in the book. It just pulled out the x squared on the bottom. But
Okay, yeah. Again, why? But you could factor out an x from both of those, but it's squared. Yeah, I mean, why would you do that? But you could. Other questions, either on this one or on another one? So that was a tricky one, because I think the best way is to do algebra first, but then it doesn't even get you out of the quotient rule. You're still stuck doing the quotient rule. But a better quotient rule than if you'd started with this guy. Other questions?
Did you go over 45?
Yes. Yep. 45 was asked last period as well. All right. The fourth root of t plus 6 cosecant t. The fourth root. There is no rule, derivative rule for roots. The only rule we know is to make it into a power and then do the power rule. So the fourth root is 1/4. So we'll make that change, and now we can use the power rule on it. We also don't know anything about cosecant yet. We'll learn one later. But you can get around memorizing the rule that I'll tell you later by doing the quotient rule, because cosecant, who is cosecant's reciprocal partner? Sine. So I could rewrite cosecant as 1 over sine, or 6 over sine in this case. And so now this is set up to be a quotient rule problem. Plus a power rule problem. So 1/4 t to the negative 3/4. That's the first one. That was an easy one. We'll clean that up algebra-wise in a minute. And then I got to come out to the side and do some work on this one. I think I said yesterday, there's some people who do product rule kind of in place because it's not hard. Derivative first times derivative second plus vice versa. I don't know of anybody who does the quotient rule in place. Like, everybody writes it out because there's just so many pieces to it. So derivative of f, if f is 6, what's the derivative of 6? 0. So don't forget, sometimes we get lost in all the complicated rules that we're going to learn, and we forget that the derivative of a constant is 0. Derivative of sine is cosine. So now I'm ready to do quotient rule. So gf prime, oh, that's kind of nice. 0 times sine of t. Don't guess I really need to write that, but just to fit the formula. Gf prime minus fg prime, 6 cosine t, over g squared. Safe stop if it's a free response question, because the rest is algebra, trig. Like, we let the underclassmen handle that stuff. We've got bigger things to worry about. So we're done with calculus. However, on a multiple choice test, there's no way that that's the answer. The answer is going to be cleaned up a little bit. The negative exponent would send it to the bottom. Minus 6 cosine of t over sine squared of t. Remember, you can put the squared either in parentheses, or you can avoid the parentheses by putting it right there. That might be a multiple choice answer. Let me give you one more potential multiple choice answer. If we do some trig tricks with this, like, what's cosine over sine? Remember what cosine over sine is? Cotangent. So cotangent of t, if we did cosine over sine. And that would leave 1 over sine, which is cosecant. That might be a multiple choice answer. So I have no doubt that you could get from our first safe stop answer to that multiple choice answer. That's pretty easy. But would you be, if you cleaned it up and you got to here, and that wasn't an answer choice, but this one was, would you figure out, oh yeah, they did some trig stuff to get to there? I hope so. Because sometimes that happens, where you work it, you get this, you start looking for answers, and it's not there. It doesn't mean you're wrong. It may mean that I, or the book, or whoever wrote the test question, pulled some tricks to change up the form of the answer.